What's the main purpose of our eyes? To see things, to give us the sense of vision. And what's the one thing that facilitates this purpose, that helps us see things? Well, light. To see any object around us, we need light. And light has various properties by which one can characterize it, and scientists have studied these properties of light for a long time. Like in 300 BC, a Greek mathematician called Euclid wrote Optica, in which he studied the properties of light, where he postulated that light traveled in straight lines. And over time, there were of course many philosophers and scientists who made their own assumptions or gave their own ideas to characterize light, some being acceptable and others not. Like, in fact, it was proved that light can bend in certain cases, which led to the concept of diffraction of light. But why so many theories of light? Isn't light just light? So shouldn't we be able to characterize light in one particular way? Well, reality is what it is. And to explain how something works, scientists put forward their own theories and with solid explanations as to why something is as it is. Say, a simple way to put it would be this. You have a box in which you have something whose properties you need to observe and come up with a model to explain how the contents of the box work. So you give some external inputs like, say, you squeeze it or smash it or throw it around and lots of other stuff. And you note down the output for that as to what happens when you do a certain thing. Now, you could come up with another box containing an arrangement of various things such that this box exhibits the exact same properties as the initial one. But that does not mean that it's the exact same thing that's there in that mystery box. It could just be one of the many things that behave similarly. Now, think of the unknown box as reality, and the new box as a model to explain how the contents of the first box work or behave. So this process is like giving a theory to explain the observed reality. So there exist multiple theories of light, and well, anything for that matter. But reality is what it is and not what someone claims it to be. So when it comes to explaining anything, it all depends on which theory you prefer to follow, which may be able to explain all the properties observed or may have some exceptions. Now, one of the main theories that pushed forward the study of light was the corpuscular theory of light, which lasted for more than a century but failed to explain certain observations like diffraction, polarization of light, and interference. Then came Christian Huygens' wave theory of light in 1678, for which a solid proof that light waves can interfere with each other, thereby creating an interference pattern instead of just a spot of light, was given by Thomas Young with his double slit experiment. Later in the 19th century, when electromagnetism was slowly being explored by greats like Faraday, Maxwell, Hertz to name a few, the electromagnetic wave theory of light came into picture. An electromagnetic wave is a wave that propagates or moves in the three-dimensional space around us due to variations in electric and magnetic fields at any point. So it does not need a medium like solid, liquid, or gas to travel through and can exist in vacuum as well. Now, one of the parameters that characterize a wave is its wavelength, and these electromagnetic waves of various wavelengths belonging to a range or a continuous spectrum of wavelengths are collectively referred to as the electromagnetic spectrum. And the word light actually refers to a portion of this electromagnetic spectrum comprising of electromagnetic waves of wavelengths about 400 to 700 nanometers. And this portion of electromagnetic waves is what can be detected by the human eye and is called light. Whereas other portions of the spectrum, like for example this region, comprises of waves that can be detected by, say, our skin, which is nothing but heat. So essentially they are the same electromagnetic waves but just of different wavelengths. Thereby their properties are different, so we sense them in different ways. This theory of light modeled as a wave seemed to explain the behavior of light just fine, until exceptions like the ultraviolet catastrophe, observations made in the photoelectric effect, posed a problem to this theory. So then came another breakthrough in the name of quantum or photon theory of light, given by none other than Albert Einstein, by which he could explain the observed properties of light in these exceptions which could not be explained by the electromagnetic theory. So does that mean that this is the theory of light that we follow and not the wave theory of light? Well, not really, because the photon theory of light could not explain certain observations, like the one made by Thomas Young in his double-slit experiment, which proved that light waves do interfere with each other. So there exist certain phenomena of light that can be explained by one of the theories and not the other. So light is said to behave as a particle under the photon theory of light and as a wave according to the electromagnetic theory of light. And that does not mean that light is two different things, that light is a particle or light is a wave. It's just that light in reality is something that cannot be fully imagined yet. Meaning there does not exist one single theory that can explain all of light's properties without any exceptions. So as of now we follow both the electromagnetic theory of light and the photon theory of light because they are the closest to what light truly is. They can explain most of the properties, but one has its own exceptions which can be explained using the other. Hey there, thanks for watching this video, and if you like this video, do give it a thumbs up. If you like it a lot, well, you could share it with your friends, and if you want to stay tuned to my channel, and well, you could just click that subscribe button and stay tuned. And also, if you have any concepts or ideas that you want me to make a video about, then well, feel free to comment below, and I will see you in the next video.